Good morning. Today I'm going to talk about database normalization, which is one of a key factor when you're doing database creation. Every time you create a database, you see your intention is not just to store data, but also to store the data in a correct place and retrieve it, that is search back as quickly as possible. So that is our main intention as a database administrator or a person working for a DBA. The topics that are covered in this session is nothing but we're going to see how an unnormalized table is going to be, what can be the issues that can happen in an unnormalized table. We're going to see when we're going to do a normalization as a step-by-step process. We're going to see 4 different forms of normalization: the first, second, third, and the BCNF. And we're going to take an example and see how an unnormalized table can be converted to a normalized and what are the advantages after normalization in each of the steps. Before going into normalization, we're going to understand what is normalization. It is nothing but I have a table where I store all the data, where the data can have different issues like something called as redundancy and anomalies. So when I store data of any kind of application, it can be in flight application, it can be an application that stores bank data, it can be an application that stores information about a store, a B2B, B2C, wherever I'm saying, it has to be a way in which I can store and retrieve data. And when I store data, I cannot store all the data in one single table. That might sound quite easy, but that is not going to be flexible, or it's not going to be secure, or it is not going to have integrity as well. So we are going to see all these kind of things. First thing is that what is data redundancy? Here the keyword redundancy is nothing but the same data being duplicated in multiple places. So when we are breaking it, we need to keep this thought process. Example, if I take a student database, I cannot collect all the information again and again. That is going to take up a lot of space. Okay, one student having Aadhaar card in 3 different tables shouldn't be a problem. Yes, but if I'm going to do for 1 lakh students, 2 byte of data for each Aadhaar card storage, then that's quite a lot of data. The next one is data integrity. How I'm going to be connected. If I'm going to store a data or remove a data, the value of data is going to be lost or not. That is data integrity. And the last one is flexibility. That is, storing of data and retrieval of data and deletion of data should be quite simple. First, we will see a little bit about anomalies before we can even enter into normalization. Anomaly, as the word suggests, there's something out of the beat. When I say insertion anomaly, I want to add a data, and if I'm going to add a data, together I have to add an unrelated data that is not at all necessary. So that is going to be insertion anomaly. Example, I'm going to enter a student details. Every time I don't need to enter the department detail along with the department building details. So that is going to be an insertion anomaly. Update anomaly. Changes I'm making in one place needs to be affected in all the other places where the same data is going to be stored. Example, if a student data is taken, his data is going to be stored in the department. His data is going to be stored with this faculty advisor as well as the college office and the controller of examination. Any change I'm making to his main personal information needs to be reflected in all these four places. If it is not done, it's an update anomaly. Same thing. Example, if I'm removing a class, by default, all the students in that class have to be removed. Rather, if I'm removing the class, but the status of all the students still remain there inside the database, that is a deletion anomaly. And as I already told you, redundancy, the same data is going to be repeated in multiple places. That is going to be a waste of space when we are handling a large amount of data. Now, we are going to see a library example where generally if a person wants to have a membership in the library, they go create a membership where they give a membership ID. The details of the person is taken, where they belong, the address, the phone number, the email ID, and a personal identification like an Aadhaar card or an SSN number is given. Other than that, if a person wants to borrow a book, the name of the book, the title of the book, the author, whatever the ID the book is going to be verified, that one, and the publisher information, the date in which the book was borrowed, when it has to be returned, in case if it's overdue, the money, all these records, if you see, if I'm going to store it in one single table, this is how it's going to look. Here, if you see, there are a lot of repetitions. The member details is being repeated again and again. The city is repeated. In case the same book is taken by multiple people, the publisher details is going to be repeated. So it is going to be a complicated database. Now we'll see how I can break down this database using the 4 rules we have seen. The first rule, the so-called first normal form. Here the rule is very simple. Every column must have an atomic value. What is the meaning of the word atomic? That is, after this, I cannot break the data anymore, and no repeating groups or arrays. So that is what almost it means the same. That is, in a column, for a particular row, I can have only one value. Example, Alice is going to have 2 phone numbers, then it is not atomic. If a member is having only one phone number in that one location, then it is fine. But rather, if Alice is going to have 2 phone numbers, then it is not atomic. It needs to be broken down. But if you see in our previous example that there is no value that is atomic. So automatically we assume our table is in first normal form. The second one is nothing but the second normal form. There are 2 conditions to this. First one, it must be in first normal form. Yes, obviously, after doing the first normal form only we can move on to the second normal form. And the second important criteria is no partial dependency. What is the meaning of partial dependency is that in case in a table there will be columns that are primary key or a composite key, and the remaining columns are called as the non-key columns. Example, student ID is going to be a primary key, but student name or the student address are all non-key columns. In that case, every non-key column must depend entirely on the primary key. So to identify a student uniquely, every data about the student must be only associated with a key value, that is his or her register number, rather than any other value. So here in this example for us, member ID and book ID are a composite key.